Okay, guys, now let's solve question 1b. We say find the partial derivatives of the function z is equals to this very term here. To solve this one here, I can call this one here my f and call this my g. Okay, so my aim now is to find z with respect to x, and after which I'll look for z with respect to y. So to solve this guy, I am going to apply the quotient rule. Okay, so by quotient rule I have f over g all prime is equals to f prime times g minus g prime times f all divided by g square. Now this is my f and this is my g. So now let me substitute directly, guys. What is my f? This is my f. Now this is my f prime, meaning I am going to differentiate this guy, okay, and put the result here. So this is a function. The numerator here is just a function of chain rule. All right, that is function of function. So I'm using the shortcut method for chain rule to work on this very one, which will give me, and this guy here is constant as well. So this will give me 3 times 3, which is 9. I have 9 open bracket. This is 3x here by chain rule plus 11y. This is 2. Now I have g. G is just on its own, so you just repeat g the way it is. 2x here plus 6y minus now g prime. Now this means I should differentiate g. So guys, if I differentiate g with respect to x only, I want to differentiate 2x plus 6y with respect to x only. Remember, I'm working now. Okay, now here I'm working with z of x, z subscript x, that is with respect to x. So to get my g prime, I'm to differentiate this guy here with respect to x. So this is constant, so therefore 0. And if I differentiate 2x, it gives me just 2 multiplied by what next now? F, you just bring it down without its derivative. Just repeat the x the way it is, and this is how I got it. Now all divided by I have g squared. This is my g. I'm just to put 2x here plus 6y all squared. Okay, so this is what we have now. So guys, what next? What do we do here now? What next? Like if you observe here very well, something will happen. Something is common. This guy and this guy here, they are common. So I can factor out this very one, which is 3x plus 11y. So if I factor out 3x here plus 11y, this is square, this is cube. I can bring out the one that has square, then open bracket. This is 9. I can drop 9 here, open bracket, drop this guy, which is 2x here plus 6y. Okay, now minus, what do I have here now? This is off already, so I should be having just 2 open bracket 3x plus 1, okay, plus 11, this. Then all over, I have it to be 2x plus 6y all square. So guys, now let's proceed. So from here now, I have here to be 3x plus 11y all square. Now let me expand the numerator, in this very bracket here. So what do I have here now? I have here to be 9 times 2 is 18. So I have 18x plus 9 times 6 would give me 54y. Now I have it to be minus 2 times 3x would give me 6x. Then minus times plus will give me minus, and 2 times 11 will give me 22y. This way, all over, I have 2x here plus 6y all square. Okay, now let's move on. So what do we have now? Let me collect like term at the numerator. Here is 3x here plus 11y all square. What do I have here now? Okay, 18x minus 6x will give me 12x Then 54, my 54y minus 22y would give me plus 32y, yeah? Now all divided by 2x plus 6y all squared. So guys, this is what I have now. Now let's move ahead to simplify this further. Now I want to do something. Now let me do something, guys. This denominator can be simplified further. So I can have this guy to be, open brackets here, 2 plus x plus 3y, then here square. Yeah, so that's how it is. That's open bracket, in bracket 2, open bracket x plus 3y, then all square. So finally I can have it to be 4 open bracket x plus 3y all square. Yeah. So this one now can be written as this. So let's proceed now. We have 3x plus 11y all square. What's common here? 4 is common, so I can factor out 4. Bring out 4 here, then open bracket. What I have here is 3x plus here should be 8y. Yeah, then all divided by this guy is 4 open bracket x here plus 3y, then all square. So guys, this guy can cancel this guy, and finally for my z of x, this would give me 3x plus 11y all square, then open bracket 3x plus 8y, then all divided by x plus 3y all square. Yeah, 3x plus 11y. Okay. Alright guys, so this is the first part of this very question. That is for this very one, which is z, z of x, z subscript x. This is what we've got. So now next we want to solve for z subscript y. Next. Okay, so now let's get for z of y. Now as we stated earlier, this is my f, this is my g. So let me get my f now, but I'm differentiating now with respect to y. So this is my f. I want to differentiate this f now with respect to y only. At this point, this 3s becomes constant, which is 0. So I'll be laying more emphasis on the one that carries y. So in this case now, if I differentiate this one now by chain rule, this will give me here will give me 33. Then open bracket, I have 3x plus 11y, then square. Okay, what I have a g. What's my g now? This is my g. My g is just g on its own without prime, so I'm not differentiating g. So g is just 2x here plus 6y. Okay, now minus, if I here, this is g prime, guys. So if I'm to differentiate this g with respect to just y, this is the g. I want to differentiate it with respect to y. So this guy is constant, so it's 0. So I just have what, 6. So this is my 6 multiplied by, guys, what I have here is f, and this is my f without prime, so no need of differentiating them. So this one becomes 3x plus 11y cubed, all divided by g square, and this is my g is 2x plus 6y all square. Okay, so guys, let's proceed from here. What's common here? If you observe here, guys, this one and this one here, they are common. This is square, this is cube, so I can factor out one that has square, which is 3x plus 11y all square, open bracket. This is off, so I have this, which is 33 inside, multiplied by this guy, which is 2x here plus 6y. Now minus, this is off the bracket, I have 6. I have one of this guy left in there, which is 3x here plus 11y this way. I'm closing this bracket, all divided by, here is I have it to be, that is the denominator remains constant, all square. Okay, so from here now let's proceed and move on. Let's see what, okay, now from here, what's common here? Okay, I have it to be is equal to 3x plus 11y all square. Now let's focus on this place, guys. This is 33, this is 6. Something is common here. I think 3 is common. Now let's bring out 3, then open bracket. The inner one have to 11, open bracket here, then 2 in bracket 2x plus 6y here minus, here should be 2 open bracket 3x plus 11y, then all over my g square, which is 2x plus 6y all square. So now we can proceed by saying this 3 can come here so long as it's this way, it is also commutative. Okay, so I have 3 here, then open bracket, I have 3x here plus 11y all square, guys. So from here I now have to, okay, I can now expand this bracket here. Okay, so what I have here now, I have 11 times 2 is 22x plus 11 times 6 is 66y minus 6x plus times minus is minus 2 times 11 and 22. Here I have it to be y, all divided by 2x plus 6y all square. Okay, so what do we do next now? Let's proceed. Okay, from here now, what do I have now? I have 3 here, open bracket 3x plus 11y square. Now we have to do 22x minus 6x, and this will give us 16x. Then next we have 66y minus 22y, definitely to be plus, and I have 44y. Now divided by, I have here to be 2x plus 6y all square. Okay, now let me still do the same thing I did in the other one, the other part here. This denominator can be written as 2 open bracket x plus 3y then all square, which is now 4 open bracket x plus 3y square. So guys, in place here can be written as 3 open bracket 3x plus 11y all square open bracket. Okay, now there is I want to factorize something here. What's common here? 4 is also common here. When we bring out 4, here becomes 4x plus 11y divided by, here becomes 4 open bracket x plus 3y then all square. So guys, let me wipe off this place. Let me wipe off this place. So finally now, you see this 4 here can cancel this 4, and I have it to be 3x plus 11y all square 4x plus 11y then all divided by x plus 3y square. So this one happens to be my the first one is z of x, so this should be z of y. So this is what I have here as my answer. Okay guys, this is the solution for Question number 1B for 2019/2020 session of Econ 103 UDUS chapter. So this is the derivative solution for question number 1B. Okay, so let's get further to question number 2.